Alright, Chapter 7, Lightning and Surge Protection. Figure 7, one ship with the number of the electrical storm, the days per year, the definition of light within current electricity flowing from the one cloud to another between the cloud and the earth. The surge, the line, large overvoltage with the developed, suddenly with electronic transmission distribution circle the cable out of the ground wire mounted over the, on the other line with the conductor provided with the protection with the direct lightning stroke with the other line with the conductor circuit. Lightning and surge arrested device with the prevent the high voltage which with the damage with the putting the building on the circuit of the providing low impedance of the path of the ground with the current with the lightning of the transition voltage with the restoring the normal with the condition building basic insulation level BIL the crest value of the voltage with the same with the full impulse voltage wave with the insulation with the stand without fail the ground lead isolating device with the high sensitive device with the separate with the ground lead with the defect with the arrestor with the ground lead with the separate with the arrestor with the lightning arrestor will be isolated with the ground permitting normal circuit operation. Alright, figure 1 ship of the line marked over the average thermal of the lightning producing the storm data each of the year per year show the class surge arrestor secondary voltage rating 1075 600 volts 650 volts distribution voltage rating 3 6 9 10 12 15 18 21 25 27 and 30 kilovolt intermediate voltage rating 3 kilovolt to 120 kilovolt station voltage rating of 3 kilovolt and above. Value valve block type of the surge arrestor silicone carbide arrestor for the surge arrestor with the silicone carbide black with a gap with the sealed porcelain casing with a grating and resist the capacitor for the control of the spark over the voltage with a gap with the table 671 through 74 the silicone carbide valve blocks function with a nonlinear resistor with a path of large surge corrections currents and limited with the power flow follow current. Table 7-1 show the basic insulation level of distribution voltage 5 kilovolts basic insulation and the level is 70 to 15 kilovolt, 95 volts, 95 basic installation level, 25 kilovolt, 125 basic installation level, 13 kilovolt, 150 basic installation level. Table 7.2 typical application data: silicon carbide distribution in the class nonlinear resistor valve type, lightning arrestors and gaps. Arrestor rating maximum ground line kilovolt root mean squared, minimum 60 hertz volt spark over the kilovolt root mean squared, maximum 1/2 over the by 40 wave kilovolt rest, maximum with the spark inside front wave kilovolt crest maximum, and then you have the discharge volt the kilovolt crest with the discharge current with the 8 to 8 times 20 microsecond with the wave shape of the cloud with the maximum crest amplitude 15 kilovolt and 15 and kilovolt amp crest maximum 5,000 10,000 20,000 65 volt amp kilovolt and crest. Typical type of application data for the silicone carbide intermediate class with nonlinear resistor valve type lightning arrestor gaps. Arrestor rating with the kilovolt and root mean square maximum valve off the maximum reseal rating of the minimum circuit value of the favor the kilovolt root mean squared underground neutral 1,100% arrestor favor the ground neutral 80% arrestor maximum front wave with impulse with the kilovolt crest maximum 100% impulse spark with 1.2 to 50 wave with the crest with kilovolt crest the minimum 60 hertz spark over the kilovolt root mean squared and maximum discharge volt with the discharge current with the 80 to 20 volt 20 wave with the kilovolt crest 1.5 kilovolt and kiloamps 1.3 kiloamps 5 kiloamps 10 kiloamps 20 kiloamps. Alright, typical application data with the silicone carbide sedation class with nonlinear resistor valve type of lightning arrestor with a gap of electrical characteristics arrestor rating with a maximum permissible lightning ground kilovolt root mean square maximum valve above maximum reseal rating with a minimum 60 hertz spark over the kilovolt root mean square maximum switching purge spark over the kilovolt crest maximum 100% 1.5 to I-40 impulse spark over the kilovolt crest maximum impulse spark over ASA front over the wave kilovolt crest maximum discharge voltage with the discharge 8 to 20 microsecond wave shape of the following crest amplitude 15 amp kilovolt crest 30,000 amp kilovolt crest 5,000 amp kilovolt crest 10,000 amp kilovolt crest 20,000 amp kilovolt crest 40,000 amp kilovolt crest and that's that table. Alright, metal oxide valve with the rest of the metal oxide surge wrap with the construct with the zinc oxide with the valve with the blocks with the valve. You can gap the table 7-5, 7-6 with the figure 7-2 with the zinc oxide valve block with the rest are effectively insulated with the electrical conductor with the ground normal electrical operating voltage with limiting the leakage current flow through an arrestor to the small valve value with the surge developed with the electrical system protected with the metal oxide surge arrestors and the arrestor valve with the block with the conducting large with the valves current with the ground with limiting of the arms over the voltage drop of the crop with the arrestor with the connection for the arrestor with the low impedance with the stress for the electrical system is below the basic insulation level, the critical insulation level of the equipment. Zinc oxide valve with the block with the disc start with the conducting sharp with the precisely voltage level of the case with the conducting the voltage fall below the same level. The arrestor zinc oxide valve blocks the character for the nonlinear for normal distribution. Arrestor NASI C2 C2 is lab with the design test requirements table. The 7 to 5 of the N or 9A low current long duration 20 surge with over the 2 Furad or 2000 second duration, 75.8 magnitude, 99B high current with short duration, 2 surge with a 4 to 10 microsecond duration, 65 kilovolt magnitude with a 9C with a duty cycle with a 22.5 kiloamp of discharge, heavy duty distribution arrestor ANSIC 62 lab of the design and test requirement. Table 7.6 in the NA low current low duration, 20 surge the 22,000 millisecond duration. 250 amp of the magnitude with a 9B high current with a short duration, 2 surges with the 4 and 10 microsecond duration, 100 kiloamp magnitude with a 9C duty cycle between 220 to 10 kiloamp discharge to 40 kiloamp discharge. The table 7 and 7.8 show the arrestor characteristics, surge arrestor selection criteria, maximum phase ground and system voltage, maximum discharge voltage, maximum continuous operating voltage, basic impulse level of the equipment to be protected, insulation protective margin equation, protective margin equal to the insulation withstand over the voltage maximum minus 1 times 100. The equation for the ANSI C62 the application guides the surge arrest maximum recommended margin is 20%. Normal duty polyhalsey metal oxide valve distributing surge arrestor electrical characteristics, rated volts with kilovolts, MTOV with the kilovolts unit catalog number is 0.5 microsecond with a kilovolt kiloamp maximum IR kilovolt with a 508 switching surge maximum IR amp kilovolt 80 to 20 8 over 20 maximum discharge kilovolt with 1.5 3, 5, 10, and 20 kiloamps, 40 kiloamps. Heavy-duty polymer hose metal oxide valve distribution class surge arrestor electrical characteristics rated kilovolt. The MTOV kilovolt unit catalog number to 5 microsecond 10 kiloamp the maximum amp kilovolt. 500 amp switching surge the maximum amp kilovolt. 8 to 20 maximum discharge kilovolt with a 1.5, 3, 5, 10, 20, and 40 kiloamps. Alright, you have your polymer lightning arrestor 3000 series corrosion-proof steel, stainless steel, line terminal standard connection, accommodated number 6 solid with a 2 0 strand steel. Nameplate information, stainless steel, top copper, aluminum line, electrode, ultrasil, silicone rubber housing, metal oxide, rare star disc, bonded solid interface, fiberglass reinforced epoxy composite, aluminum ground, electrode, optional insulated hanger, kilovolt rating visible for the ground, optional isolator ground lead disconnector, 300 series stainless steel ground terminal, standard connectors accommodated with the number 6 solid with number 202 and 2 and 1 stranded leads, cutaway illustration, ultrasil house, Veristar distribution arrestor. Alright, this shows the rise in polymer house metal oxide valve distribution class surge arrestor electrical characteristics. Cycle the voltage rating kilovolt with the MTOV kilovolt, the catalog number 5 microsecond, 10 kiloamp kilovolts, 500 amp switching surge maximum amp kilovolt, 8 to 20 maximum discharge kilovolt, 1.5 2, 3, 5, 10, 20 kiloamps. Alright, 7 to 8, commonly applied voltage rating, the rest of system voltage, the kilovolt root means square nominal maximum recommended arrestor rating, the IE C62.2 kilovolt root mean squared, 4-wire multi-ground neutral, 3-wire solidly grounded neutral delta ungrounded Y. Alright, determine the margin for the both nominal normal duty, heavy duty MOV arrestor for the 15 kilovolt class with the 13,200, 7,000 over 7,620 kilovolt 4-wire overhead system utilizing the 20 kiloamp of the 8 to 20 kilovolt discharge volt. Solution from the table 7 of the 1 kilovolt equipment class for the basic and basic insulation level is 95 of the table 7 8 with a 10 kilovolt rated arrestor utilized with the corresponding maximum discharge voltage 41.5 normal duty arrestor table 75 37.5 heavy duty arrestor table 76. You have your protective margin equal to the insulated withstand over the voltage maximum minus 1 times 100. You get the normal duty arrestor protective margin and the heavy duty arrestor protective margin. No, not included with the effect for the faster rates for the current issue with the discharge voltage, the reduced insulation level of the various factors aligned with the ground lead. Figure 7.3 show for the components compromise the dead front elbow arresters. Favoring 7 to 9 show for the characteristics of the dead front elbow arresters. Show the 7.3 show the dead front elbow arresters and example determine the margin protection for the 15 kilovolt underground system utilized with the rise pole arrestor. Utilize both of the riser, pole arresters, elbow arresters, open point. Assuming the arrestor lead length is 5 feet with utilize the 20 kiloamp to 8 to 20 kilovolt discharge. Solution protective margin equal to the insulation withstand over the voltage max minus 1 times 100. Protective margin calculation arrestor only at the rise of the pole for the cable. Utilizing only the arrestor of the riser pole voltage maximum consists both of the arrestor discharge volt of the arrestor lead length calculated is 1.6 kilovolt amp per foot voltage maximum is double because of the reflection of the wave open of the point underground system voltage maximum equal to 2 times the discharge volt of the arrestor plus the voltage drop caused by the arrestor lead length from table 7 to 7 to 10 kilovolt 20 kiloamp to 80 per 20 maximum discharge voltage is 2.98. The drop the voltage drop covered with the 5 foot arrestor lead length with 5.16 or 8.0 kilovolts. Alright, table 79, show the dead end front elbow electrical characteristics voltage room kilovolt root mean squared MCOV kilovolt root mean squared equivalent FOW for the kilovolt crest maximum discharge volt for the kilovolt crest U for the 80 to 20 U microsecond current wave 1.5 3.5 and 10 kiloamps. Protective voltage max is equal to 2 times 20. Show the protection margin is equal to insulated withstand over the voltage max minus 1 times 10. Show the protection margin calculation rest of both of the riser pole with the open point. In this case, use length of the arrestor of the riser pole with the open point of the underground system voltage max. If the resistor of the discharge voltage of the arrestor lead length with a calculated 1.6 kilovolt per feet, some percent of the front wave voltage of the open arrestor with the percent typically between 15 to 40% of the calculation value to 30%. Voltage max the discharge voltage of the arrestor plus the arrestor's lead length voltage drop plus 0.3 times the open point flow voltage. Table 77 of the 10 kilovolt, 20 kilovolt with the 8 to 20 and maximum discharge volt is 29.8 with the voltage drop of the 5 feet lead length of the 5.16 times or 8.0 kilovolt with the finally table 79 open from the FOW voltage for the 10 kilovolt arrestor 38 points for the purpose of the calculation. 30% of the 38.7 is equal to 11.16. Once again, that was chapter 7. Let's move on to chapter 8, fuses.